Hello, hello, hello. Good afternoon, good evening, good night, good morning, wherever you are in the world. And again, welcome to another stream here in Freaky Physics. Hold on. My lab coat's in the wash right now. Okay, so for today we have CJ. Again, we are gonna do some past paper practice for IB. So all right. So with that, okay, I'll just wait for him to get in and we will get started soon. Okay. Oops, I want to check. Oops. Okay, let's stay here first while we wait. Okay, so while we're waiting, so we're gonna do paper one. We just finished the paper 3 questions yesterday, and we're doing paper one, the multiple choice paper. So we're gonna go through some multiple choice questions rather. And again, we're gonna, since this is multiple choice, we're just gonna rationalize. We're just gonna uh, explain everything as briefly as possible, so we can cover at least half of the paper for today. All right, we don't have anyone in the chat yet, but yeah, it's fine. CJ is also not in yet, so let's wait while. Let's wait for a while. Let me also send him a message now. He's in. Okay. All right, let's get in here. Hi, CJ.
Mr. Dennis.
Right. Good evening. Okay. Are you ready?
Yes.
Okay. So let's do paper one. All right. I have here paper one from 2021. Okay.
Okay.
All right. So first, let me just get ready with the board first. There we go. Okay, so I'm gonna put the question right away, and here's the very first question. You know what? I'll copy a few questions at a time.
Mm-hmm.
Okay, never mind. The second question's a bit big. So let's do the first question here. All right, this one's pretty straightforward. There should be an answer for this question.
Okay.
Okay, so which lists one scalar and
How
two
was the
vector
scalar?
quantities?
D.
D. All right, that's correct. D is correct. Wow. Okay, not even batting an eyelid there or an eyelash.
I always look at D first for some reason,
Okay.
even though it's the least common one,
Mm-hmm.
the least likely.
Uh, Actually, when I checked, I'm not sure if this is true for all exams, but for a lot of exams, IB probably this isn't true. But what I
For
noticed,
Chinese, it's C.
yeah, Chinese is C. Interesting. Okay. All right. So here's the second question. I think I'll zoom out.
C, B, A, D. That's the order of
Mm-hmm.
popularity.
All right. Well, for me, I just really randomize everything, so there's no preference. I actually use a randomizer
Mm-hmm.
when I make an exam.
Mm-hmm.
Okay. Anyway, so
Oh.
here number two,
Oh. Okay.
because I know I have a tendency to select C if I was left
Mm-hmm.
to my own devices.
Mm-hmm.
All right. Let's go to two. So which of the following? We have two sets of data shown below with circles and okay. Let me zoom out a bit again. Circles and squares are obtained in two experiments. The size of the error bars are the same for all points. Which is correct about the absolute uncertainty and fractional uncertainty of the y-intercept of the two lines of best fit? This is gonna be, I don't know, a bit tricky, but I think it's still easy.
Oh, I look at the error bars.
Mm-hmm.
It looks like a 0.5
Okay.
for each of them. Oh, there's no number. Which is
Okay.
same.
The absolute uncertainty and the fractional uncertainty.
It's,
Remember, we're talking only about the y-intercept, not the actual data points. Okay.
mhm.
So,
Oh, the fractional uncertainty
mhm.
is larger for squares then.
Okay, so your answer is
D.
D, also correct. Okay. Let's rationalize that real quickly, why that's the answer. Okay, can you tell me your reasoning behind it?
Because they have the same error bars,
Same
so I
error
thought they
bars.
had the same uncertainty.
Okay, so correct, same error bars.
And you said larger numerator
Mm-hmm.
wait, meant
So either
bigger
large
uncertainty,
numerator or small denominator would mean
higher uncertainty.
high uncertainty. So in this case, smaller numerator, right? A smaller denominator.
Mhm.
Great. Okay, good. So you're picking up a lot of the things we've been doing together. So great. All right, let's do the next few questions. Oops, undo. Undo one, and let's paste that again. All right, so we have the next three questions here. So the first one is a large stone. Number three, a large stone is dropped from a tall building. What is correct about the speed of the stone after 1 second?
Um, the speed
Dropped, okay.
increase.
So remember, it's dropped.
It is decreasing at an increasing rate. Yes, it is decreasing at a mm,
Okay,
the speed is
okay.
increasing at an
Increasing or
increasing
decreasing?
rate.
All right.
It's C.
It's C. Okay, correct answer is D.
What?
Okay, you're
It's,
right. Okay, so the first one is the speed is increasing itself, right? In
mhm,
other words, it's getting faster. It's going faster every second, right?
mhm.
Now, here, now remember when we
Oh
do
no! This terminal velocity.
yes, exactly.
So there's a time where it doesn't increase.
So ideally, the acceleration is constant here. Ideally, right?
Mhm.
Okay, constant, meaning um the rate of change in the speed is constant, right? Rate of change in speed is constant, right? However, you have to be a bit careful here because sometimes in reality, as you said, you have terminal velocity, right?
Yeah.
Reality. Why do we have terminal velocity? There's air resistance, right? So because there's air resistance, that decreases acceleration. Okay. So that leads to the answer of D. All right.
Mhm.
Okay. Number four. The graph shows the position of an object, how it varies with time in an interval from 0 to 3 seconds. At which point does the instantaneous speed of the object equal its average speed over the interval from 0 to 3 seconds?
Hmm. So what point marks the average?
Okay. So
What
what's the
is the
average
average speed?
speed?
1. Wait. It's around 1.
Okay. Number 4, right?
No.
Ah, okay. I see. I see. All right. Uh,
Mm. Mm. Hmm? Do we do?
okay.
What do we do?
All right. So what's
Distance over
average
time?
speed first? Yes, correct. So average speed is distance, but what distance? We're talking total distance. Okay. So
Mm-hmm.
average speed equals total distance over total time, right?
Mm-hmm.
So you can already guess that that should be uh 3.5 over 3. You don't even have to calculate the actual value. Just think 3.5
Yeah.
over 3. So it should be a bit bigger than 1, right? It should be a
Mm-hmm.
bit bigger than 1. Second thing, we're going to look at an average speed that's just a little bit bigger than 1, right? Uh okay, let's take a look at, sorry, not 1. It should be the total distance is 1 to 3 point, so 2.5. My mistake there. So this will be 2.5 over 3. So that's approximately zero point 0.6, right?
Wait, why is it 2.5?
Because remember, you start from 1. You don't start from 0. You start from 1. Then you end up at 3.
Oh,
No,
yeah, that
not
makes
3, but
sense.
to this 3.5. So from 1 to
Mm-hmm.
3.5, so this means this is 2.5. The distance traveled is 2.5. Okay. So
Mm-hmm.
approximately zero point 0.6. And which of those speeds will give you an approximate speed of zero point 0.6? So we have to look at A, obviously not A, because you're still at the starting point, right?
Mm-hmm.
B, you're still too close to 1. So it's not yet a big change. So in this case, this is still a small speed, right? In this
C
case,
is also close to 1.
C is close to 1, but which one is C? The actual answer here is C.
But it's close to 1.
Okay,
Just
why is that
barely.
C? Because that is approximately
It's
uh,
below 1, right? Just
mhm,
slightly.
uh-huh. So it's here. So that's average speed, right? How do you find instantaneous speed? This is going to be the slope of tangent. Okay.
Mm-hmm.
So in other words, in here, let's zoom in a bit so we can do the tangent thing. Okay. So if we draw the tangent lines here, at 1 it's like this. At B, it's more like that. And then here at C, it's more like that. Which one is closest to zero point 0.6? And if you look at D, it's that. Which one is closest to zero point 0.6?
For the
Yes.
slope,
The slope of which tangent line is closest to zero point 0.6? What's the slope of the tangent line at A? It's 0, right?
mhm,
Okay. What's the slope here at
D,
1 second? It's less than zero point
right?
0.6. Here at D, it's definitely beyond 1, right? So we, by process of elimination, the answer is C.
Mm-hmm.
Okay. Uh, all right. Questions?
No questions.
Okay. On the stream, hey, what's up? Okay. Oh, this is funny. He said, "What's up?" But I already put in a list of blocked words, and yeah, part of "What's up" got blocked.
Oh,
Okay. S-
oh, oh, I wonder what the list was.
Okay. Well, banned words. I looked for a few banned words before. All right, let's go to 5. A
Hmm.
car takes 20 minutes to climb a hill at a constant speed. The mass of the car is 1,200 kilograms, and the car gains a gravitational potential energy of a rate of 6 kilowatts. Take the acceleration due to gravity to be 10. What's the height of the hill?
Suva? No.
You can do Suvat, but you remember the order the order that you try. You always try energy first, because a lot of the time that's
Mm,
easier. So energy, then Suvat, then momentum. Sorry, energy, then forces, then Suvat, then momentum, in that order. Okay.
Energy.
And I already know I'll use energy because it told you what the gain in kinetic energy is.
Yeah.
Yeah. Okay.
6 kilowatts
6
equal mv
kilowatts.
squared.
Okay. What's the height of the hill and the mass is there? Okay.
Okay. So. Uh,
Now
what
remember
was that?
when we do energy, we do conservation of energy.
Mhm. Wait. Do I can? Okay. So we use the energy first, and then go to see that.
Mm-hmm. Try using energy first. If you can solve it, then it's done. If you cannot, go to Suvat. Then if you cannot,
For energy,
forces, yeah.
is
Or but
we do
remember,
the
whatever the
second
problem
equation for
is,
2 by 2.
yeah, whatever the problem is, sorry, you need the easiest way to solve any problem is to draw it first, right? So you can see something. See if you can recognize anything.
Draw it,
Okay,
but it's potential energy.
there's potential energy, right?
So I don't find the kinetic energy.
Mm-hmm.
Okay. Then 6,000 divided by 1,200 times. Okay,
Okay.
12,000. Okay, so it's one half.
Uh-huh.
Um, one half is the height. So 0.6.
That's that doesn't sound right. One half doesn't go with
Wait,
GPE, right? One half goes with kinetic energy.
uh-huh.
Okay. All right. I'll give you one tip. This is an exam tip here. Look at your numbers and see which ones you can already eliminate. You can eliminate two numbers right away.
A,
A and
B.
A and B. Definitely eliminated, right? Too small.
Mhm.
No matter what you do. Okay. All right. Shall I give you help here?
Let me think. I use the time.
Okay.
Uh,
Yes, you have to use the time, correct.
I thought I
Excuse me.
found the change in height.
All right.
What's the change in height?
I'm gonna help you out with the illustration again, right? So here's your car. The car starts here at the bottom of the hill and it goes straight up, right? Remember, the speed is constant.
Yes.
Okay. So whatever the kinetic energy here must be the same as the kinetic energy here, right?
Mhm.
Okay. So let's say it's got a value C. This will also be a value C. Doesn't matter what it is, right? Now, also here, what's a GPE here? That's 0, right?
Yeah.
And then if the hill has a height h, then the GPE here is mgh, right? Okay. So let's go now to the idea. So again, work done is equal to the change in the energy, right? So you start with this idea, and what's the only energy here changing?
The the kinetic energy and potential energy.
But the kinetic energy is constant, right?
Okay, so gravitational potential energy is
Uh-uh. So the work done will.
6,000 at the top
Mhm.
and 0 at the bottom.
Okay. It's not actually there yet because this is not energy, this is power, right?
Mm.
Okay, that should give you the biggest hint there. So the idea here is
Oh,
we're gonna write this out first as the work done equals change in the energy, and this is equal to just the mgh. Well, technically minus 0, right? But the
energy
0.
over time.
Mm-hmm. And then if we divide this by time, this is equal to the power, right? Right. So
Wait,
okay,
yeah,
since we're looking for the height, we just rewrite that as height is equal to power times time over gh. right? And we know, sorry, not GH, just over
G.
G, right? We know the power, 6 kilowatts. We know the time, 20 minutes, but you have to convert that to seconds, right? Okay. So what I'm gonna do, and again, this is something that can be easily done with this paper because you're not allowed a calculator. You just really need to put the values in. Uh, I'm missing something, aren't I? I'm missing the M there.
And
M. So this is gonna be the mass is 1,200. Okay. And then the power given is 6,000. And then the time is 20 minutes. But we have to multiply that by 60 to get seconds, right? Now, in this case, the way I do it, I'm not going to multiply the 20 and 60 anymore. I'm just going to look for stuff that cancels out straight away. So, first of all, 60 and, okay, 60 and 120 gives you 2. Then this is 20, gives you 0. That gives you 1. Then this 0 and that 0 gives you, they cancel out. So we're left with 600. So the answer is
600 C.
600C. Okay. All right. So I think this is, in my opinion, this question is one of the harder ones in terms of reasoning it out. So if you don't get it right away, it's fine again. Yeah. All right.
Mhm.
Okay. But you did understand how we should solve it, right?
Got it? Yeah.
Got it. Great. Let's go to 6 and 7. Okay. Okay, so a ball undergoes the first one, an elastic collision with a vertical wall. Which of the following is equal to 0? Is it the change in the magnitude of linear momentum of the ball, the magnitude of the change of linear momentum in the ball, the rate of change in linear momentum, or the impulse on the
What
ball?
is impulse?
Okay, I guess I better do that first. Okay, impulse. Let's define this. This is simply the change, nothing else, but it's just the change in momentum. Okay. Now this is also equal to force times time. Where but this by definition this is impulse. Okay. But in
Mhm.
formula form, you include equals ft for impulse. All right. So let's go back here. Let's go back here. So what is 0?
Um,
This is, I'm gonna say this much. This is a tricky, and this is a tricky one because of the wording of the choices.
is it D?
It's not D.
Okay. Then let's check out the wording.
Okay, let me give you another clue here. Elastic. So if there's an elastic collision,
Does that mean
then
momentum is conserved?
that's part of it, and then the other part of it is kinetic energy is conserved.
Yeah.
Okay, kinetic energy is conserved.
What is linear momentum?
Okay.
Mm, The ch- this is rate of change, change of magnitude,
Mm-hmm.
magnitude of the change, the rate of change. C.
C. Mm-hmm. The correct answer here
Is it
is
not?
A. This is tricky.
Okay, I don't get it.
Okay. Let's go back to the idea first. So you have your wall, right? And the problem is always like this. There's always some sort of problem like this. It's usually worded in many different ways. But the idea is always in paper 1, you have an object coming in at a velocity v, and you have another, and then after it bounces off, in the opposite direction with a velocity of negative v, right? Okay.
Mhm.
The idea here, why is A the answer? Let's take a look at that. It goes the change in the magnitude. So we're going to look at the magnitudes first. Since magnitudes are what we look at first, we ignore direction, right? So in both of in the before and after, the ball is moving at the same speed. If it was coming into the wall at 10 meters per second, it bounces off the wall at 10 meters per second, right? So what's the difference
Mhm.
in their magnitudes? Again, if you ignore direction only and only focus on the magnitude, what's the difference in momentum? What's the difference in the velocities? If one is 10 and the other one is 10 in the opposite direction, what's the difference in their
Oh,
speeds? Not the velocity, but the speed.
20. Wait,
The, the difference in the velocity is 20, correct. But what's the difference in the
yeah,
speed?
0.
0. So A is telling you what's the difference in this. What's the difference? If the speed difference is 0, then that means the momentum difference is also 0. Only counting the magnitude. Okay. So in A, magnitude first, then find the difference. So this is 1, this is 2. Okay. So in B, you do the change in the momentum first. You find the difference first, and then you look at the magnitude. So in this case, in A, this is 0. In B, this is your 20.
Wait, so what is meant by linear
Uh,
momentum?
good question. I'm gonna say this now, at least for you. You can ignore the word linear. You can ignore that. Okay.
Mhm.
The reason why you can do that is because the other kind of momentum that's important, angular momentum, is only discussed very briefly and not even in detail in topic 7. If you want to study
Oh,
linear momentum, it's going to be in the engineering physics option, which is option A. And you're not taking option A, right?
never done.
Okay, so that's the idea there. Okay, so the change in the magnitude of the linear momentum is 0 because you take whatever the momentum is first and then you find the difference of the magnitudes only. Ignore direction. In 2, you don't ignore direction. So in this case, ignore direction. Ignore direction. Here, do not ignore, right? Do not ignore the direction here. All right. Okay. I think we need to go through that later again for more details. Okay. So let's go to the next question, number 7. Um, two forces act on an object in different directions. The magnitudes of the forces are those 18 and 27. And then the mass of the object is 9 kilograms. What is a possible value for the acceleration of the object? Hmm. Okay, got it. I already know the answer.
Um, and I just
Okay.
so F
Um,
equal M A
correct. You
F
start with that.
divided by M is
Equals
um,
A,
2
right?
and 3.
Mm-hmm. Now, here's the thing. I'll give you one clue. Those directions do not necessarily have to be opposite. It just says different, but it doesn't necessarily mean opposite.
Mhm.
Okay.
Do I
All
add
right.
them up?
You have to add them up in a certain way, right? But I'll give you a okay. I think I'll give you a clue. All right. So You have these two forces, right? What is the minimum resultant force?
50,
Just
no,
the magnitude. We
45.
don't. Um, that's the maximum, right?
Mhm.
The maximum resultant is equal to 45 newtons. What's the minimum resultant?
Hmm.
Well, think about it. Minimum means the two forces are acting in opposite directions.
So they're not acting on each other?
If they're acting in opposite directions, one is 18, the other is 27. What's the resultant force for
Yeah.
that?
So I just subtract 9.
So that's going to be 9 newtons. Correct, because you subtract it, right? So let's take a look here. You said that F equals ma, and then from there A equals F over m, right? So what's the minimum and the maximum acceleration? So the acceleration here is what, and what's the acceleration here?
Okay. Uh, is that a
Remember that
9?
your mass is 9.
That's a 9.
So the acceleration for the minimum is,
Wait.
okay, so that's going to be
F
the force
is
divided by 9,
9.
right? Because the mass is 9
1. It's
kilograms.
1 then.
So the first one, the minimum acceleration is 1. And what's the maximum?
Um,
Again, just the magnitude. We
5.
don't care about direction. 5. Which value is between those values?
Three.
Which choice is between 1 and 5? It is only C.
C.
Okay. All right. Now, one thing you can already eliminate is A. Okay. Because if A was the answer, then the forces must be equal and opposite.
Mhm.
Okay. Um, so this is a technique that a lot of students still struggle with when they're looking at two forces. You always think of a minimum and maximum in these kinds of problems. And this kind of problem appears quite often to, to make sure that you note whatever the answer, how to answer it. Okay.
Mhm.
All right. Okay. Let me get to the question now. Number 8. Okay. Question number 8 is you have two boxes. Hold on. Okay, here's number 8. So two identical boxes are stored in a warehouse as shown in that diagram. So they're stored, okay? Two forces acting on the top box and two forces are acting on the bottom box as shown. Which of the following is a force pair according to Newton's third law? So 1
Mm,
and 2, 3 and
okay.
4, 2 and 3, 2 and 4.
Um, to me, 2 and 3 makes sense. Because if you thought the third law is if you put a force on something, the same equal force is pushed back on you.
Mm-hmm. Right.
And the lines are the same, and it's the only one where there's two lines going opposite direction.
Okay. So that's a very good hint. Number 1 is the
But
length
it's
of
not.
the lines. Okay. And number 2, you said they must be equal and opposite. So the equal part is the
Mhm.
length and the opposite part is the direction, right?
Yeah.
So what's your final answer?
Let's see.
C. And that's correct.
Let's
Okay.
go.
All right. Great.
Mhm.
Let's move on. Uh, okay. Let's go to 9. Okay. All right, so here is the next question here for number 9. So you have an electron and it has a linear momentum given there. So what's the magnitude? What's the order of magnitude rather of the kinetic energy of the proton or the electron? Ooh. Okay, I think you need a value from the data booklet. Okay, so I'll give you something from the booklet. I'll give you the mass of the electron here.
Hmm.
Okay. Here we go. Okay. I think you should be able to easily guess this now.
Really?
Uh-huh.
What's the order of magnitude? I don't know what that means.
Okay. Let me see if there's
Um,
something in the booklet that could be helpful. If there is, I'll paste it up here.
it could
Okay,
just
there
be.
is something here.
Uh,
There's something here. Hold on. I'll paste it. Okay. So this is again some very good practice. If you don't know how to answer it, look at the data booklet for something relevant. Okay? So that's our relevant thing from the booklet. I'll put it here first. I'll move it out later. Hmm.
mm,
Hmm. I can already see the answer.
1/2 MVs.
Uh-huh.
KGMS.
Uh-huh.
KGMS. Wait, that just means MV.
Mm-hmm.
Half of 4 times 10 2. EK.
Okay.
KE. 2 times 10 to the 25.
Okay. Look in the momentum
Oh,
side.
oh, okay. The momentum is 4 times 10 to the 5.
Mm-hmm.
So, mm, what's the mass? Oh, we have the mass as well.
Mm-hmm. You're give
Um, so 4 times 10 to the 5
mm-hmm.
divided by 18 times 10 to the 31.
Mm-hmm.
So it's like 4.5. No, it's one
Okay,
four.
remember what formula are you using here now? Can you tell me which formula you're using?
Not the third one.
From momentum, right? Or from
Yeah,
energy. Okay, the third one from momentum
momentum.
is the correct formula to use here.
Do we not? Oh, it's squared.
Mm-hmm. Yes, it's p squared, momentum squared.
Okay, let me write this down. Um, P squared.
Mm-hmm.
Sorry.
All right, so let's just do that right here, okay? So remember, your momentum is given. So that's going to be 16 times, the p squared is equal to 16 times 10
I think
to
it's
the
16 over 18.
50, negative 50, right? Then you're going to divide that
Oh,
by 2m. That's going to be 2 times the mass. It's going to be, that's more approximately 18 times 10 to the minus 31, right?
mhm.
So what's left? So basically you're left with, uh,
Wait, why is it 2 times 18?
because the 2 is part of the formula right there,
Yeah,
right? And then what's
no,
the,
I said 18 after multiplying it.
okay, sorry, that should not be 18. That should be 9. It should be 9. You're right. Right? So what happens? That's 2 times 9 makes 18 and 16. That more or less cancels out. More or less, right? And then 50, 10 to the 50 divided by 10 to the negative 31 gives you 10 to the
Sorry, what
minus.
you said?
Okay, so this and this more or less cancel out, right?
Really?
They don't exactly
Because
cancel
we're
out.
not looking at them.
Yeah.
Because we're not looking at it.
Hold on. Let me zoom. Okay. Let me scoot that over. So um, again, the 16 and the 2 times 9, that's 18. They more or less cancel out because we're only looking for order of magnitude. We don't need an exact answer. So more or less is okay, right? So that more or less cancels out. And then 10 to the 50, 10 to the minus 31, and 10 to the minus 50. These two cancel out, give you negative 19, right?
19.
So this is
Uh,
approximately 1 times 10 to the minus 19. So what's your answer here? The answer here is therefore
C.
C. Okay. All right. I'll try to move that now. There. Make that smaller. Okay, let's go to the next question. Which aspect of thermal physics is best explained by the molecular kinetic model?
Um, so Avogadro's gas, right?
Okay.
Um, I don't know D, so I think get rid of D
Okay.
and
You
B.
have to kind of know this. You need to memorize this. Okay. Basically, the answer here is A. Okay. Kinetic model is the equation for state of ideal gases because of the word ideal gases already being there. Okay. So again, the molecular kinetic model explains ideal gases very well. Now, D is more for the existence of gaseous isotopes. This is more on nuclear physics, right?
Mhm.
The difference between the Celsius and Kelvin scale is more on ideal gas laws only, not necessarily the kinetic model. Okay. And the value of the Avogadro constant is also mostly from ideal gas laws. Okay. Again, you really have to memorize this particular aspects. What is explained by what? Okay. Move on to number 11. So um okay, when 40 kilojoules of energy is transferred to a quantity of a liquid substance, its temperature increases by 20 K. When 600 joules of energy is transferred to the same amount of liquid, at its boiling temperature, it vaporizes completely at a constant temperature. So what's the specific latent heat of vaporization to the specifically heat capacity? Okay, I'll give you a clue here. It says same quantity. So again, when you have the same quantity, you're comparing two things. What do you do? I'll also be
Ratio.
pasting, yeah, also be pasting the relevant formula equations here.
It's like a combination
Mm-hmm.
between the two for 3.1.
It is a combination between the two, right?
Mhm. Um,
We went pretty fast today. 11 out of 30. I think we can make it to like one more number, one or two more numbers after this.
sure.
Okay.
And, okay, so I use the top equation first.
Mm-hmm.
So I do like um, 40 times 10 to the 3 equals
Mm-hmm.
C delta T because the mass should be the
Mm-hmm.
same.
Mm-hmm.
And the C is the same.
Right.
No,
No, they're not. They're
C
not.
is the same for each.
Yeah,
Oh,
C is the same for both, but it only applies for one side of the equation, right?
mhm. C and then 20. So we're finding C. So um, 40 times 10 to the 3 divided by 20.
Mm-hmm.
So it's 20, wait, 20 times 10 to the 3 at the bottom.
Okay.
Mm. Oh my
All
God.
right. So what's your answer?
And then at the top, um, 600 times 10 to the 3.
Okay. Which
Oh,
one
is
can
the
we
latent heat.
With what can we eliminate now, by the way? What
A
can
and
we
B.
definitely eliminate? What? A and?
A and
A
B.
and B. All right. Between the two, you can also eliminate one without solving for it.
D,
Why D?
because that's just temperature.
Uh-huh. It could Here's the thing though. You're correct to eliminate D, A, and D, but not for the correct reason. Okay. So
Oh,
in this case, the correct answer is indeed C. Okay. Uh okay, we'll reason it out without actually solving for anything. Okay. Number 11. Okay, sorry, my mistake. It's not C, it is D. The
okay.
correct answer is D. Okay. Why? Because of this. Remember, we're looking for specific latent heat over heat capacity, right? So if we write this here, I'm gonna write this Q1 over Q2 is equal to, and then we want latent heat as Q1, right? So I'm gonna write here ML over MC delta T, right? So what cancels out? M immediately cancels out. We're looking for L over C. So from here, L over C, I'll just write this here, this. L over C now is equal to Q1 delta T over Q2. Without solving anything else, I can already see that since Q1 and Q2 have the same unit, our answer should have a unit of temperature. Unit is temperature is K. Okay. So in other words, that eliminates A and that eliminates C. Now, to solve it, let's just take a look at Q1 and Q2. Which one's bigger? Q2 is bigger, way bigger, right?
Yeah.
And
Yeah.
then so that's going to give you 600 over 40. It's going to give you 15, and then you're going to multiply that by the change in temperature of 20. So that definitely gives us D. Okay.
Mm.
Again, I'll just put this here. L over C is equal to 600 times 20 over 40. Let's cancel stuff out. This becomes 2. So 600 by 2 gives you 300. Okay. All right. Last question for today, CJ. Let's do that. Number 1. Number 12.
Okay. Wait, how did you know the unit is K again?
Sorry.
How did you know the unit was K?
Okay. In Okay, let's go back here. So if we focus back here, we this is where we start again, right?
Yeah.
Now, when we start there, we just isolate everything so that we have L over C because that's what we have here. and our L over C is already here, right? So we
Mm.
move everything else. L over C is equal to Q1 over Q2 times delta T. So Q1 and Q2, they have the same unit. It's going to be joules. So they cancel out. The units cancel out. And there, the only thing with the unit is temperature delta T. The temperature change delta T. So we know that from here that since delta T is in the numerator, the unit is K. If delta T was in the denominator, then the answer would be either A or C.
Mm.
Okay, so that's where we find the unit, the correct unit, and then for the actual answer, it's just this. For the actual value or the actual magnitude of the answer, it's just that.
Yeah.
Okay, all right. Okay, let's do one more for today. Number 12 is okay. Okay, last question for today. So a quantity of 2 moles of an ideal gas is maintained at a temperature of 127 degrees Celsius in a container of volume 0.083 cubic meters. What's the pressure of the gas? What formula do we use here? Let's make it
Mm.
easy and you just choose from these guys. Okay, there.
PV NRT.
Mm-hmm.
Um, so we divide by volume, so
Mm-hmm.
equal
So we have it.
NRT. I think we can we get rid of NRT? No, we can't.
Sorry, say
Or
that again.
R, I mean. R is a constant, right?
Yes, R is a constant. The value of
And
R
N
is
is 2.
ideal gas constant. I'll just give you the value here as well. Mhm. Here.
Um, so already. So I got 2 times 8.31 times 127
Mm-hmm.
divided by 0.083.
Okay, I'm gonna
Hmm.
stop you right there. You're not gonna get the correct answer with that. Remember, the temperature must be in
oh,
Kelvin.
oh,
For
273
mm-hmm.
C equals 273
Uh-huh.
plus, so minus
No, plus.
plus,
Think about
so
it
it's
this way.
300.
Celsius is
No,
always smaller
sorry.
than Kelvin. Okay?
Mhm.
Celsius is always smaller than Kelvin.
Oh, 300 Kelvin.
Mm. No, it's not 300.
127 plus
Plus
273.
273.
Um, 400.
400. Okay.
16 times. I'm just saying 16
Mm-hmm.
times 4, 64 something
Mm-hmm.
divided by, hmm, what is 100th of that? Or 1/10 of that?
Mm-hmm.
Six. Wait, why is it 64 when everything else is not 64?
Okay. So let's just put it in here. So N is the number of moles. Oops.
Mm-hmm.
What just happened?
Maybe you made a new tab again?
Probably
Oh, you
not.
did.
Okay, let me refresh that. Okay, so the idea there is once you have the ideal gas law, there we go. Okay, so once you have the ideal gas law, all you have to do is put in the values and solve for whatever you need to solve for, right?
Mm-hmm.
Okay, here we go. So that's the idea. P equals nRT over V, and then we just put in our values. Our N is 2, our R is 8.3. In fact, I'm just gonna go 8.3. Okay, not even 8.31. The T is as you said 400 all over 0.083. So this cancels out with that, and this
Yeah.
becomes
One.
1, 2, 10, right? Oh, not 10, 100.
Yeah.
So we're left with 8. Okay, that's gonna give you 8. Then 1, 2, 3, 4, 2, 2, 3, 4 zeros. So that's 80,000, and that's gonna be 80 kPa. Okay, so our answer
Mm-hmm.
is D.
Mm.
Okay, what did you miss? What's the step that you missed?
I saw the canceling out part,
Mm-hmm.
but I found out it was like times like it was 100 to 1.
Mm-hmm.
I just didn't finish it.
Okay. So just make sure you finish it in the actual exam. Yeah. All right. So that's it for tonight, CJ. Any questions before we end?
No,
No. All right. So tomorrow again, we'll continue
tomorrow.
where from here. So we'll continue with number
Like
13 tomorrow.
tomorrow. Can I move it to Wednesday?
Sure.
Like,
Sure. No
thank you.
problem.
Thank you.
Okay. All right then. So okay, let's move it to Wednesday. I'll see you on Wednesday then. Okay. Um. Okay. I'll just check the calendar before anything else there. Okay. All right. So
Okay.
hey, somebody from Thailand said hi on the stream.
How do you know?
The writing is I'm not 100% sure, but it does look like Thai. The writing on the name
Uh,
on their name, their user ID.
on YouTube?
Yeah, on YouTube. So on the stream.
Let me see.
So I'm just gonna say hi as well. Hi there.
Oh, they're at 10.
It's Thai, right?
Yeah.
All right. Okay. Time to find out if you know the guy.
No, I don't.
You don't. All right. Okay.
I don't
So
think I do.
all right. Oh, if you want to, because I do tell my students to, visit here whenever we stream, but nobody did it during the break. I don't know why. But yeah, if you want
Because
your
it's their
friends to
break.
join the stream, if you want your friends to join the stream, I'm fine with it. You can let them know about
That's
it.
true.
All right.
Hmm.
Okay.
But it's their break,
Yeah, it's also their break. Good
fortunately.
point. All right. So we'll just continue again on Wednesday. So I'll see you then. All right. Bye bye, CJ. Have a good
Okay.
evening.
Alright, you too.
Okay. All right. So that's the end of the stream, guys. Or the end of the lesson. So again, if you're still there, whoever you were, sorry, I cannot read Thai, so I can't really read your name, but hi. And for the one in Twitch, the one who said hi as well, the one who said what's up, that's Diggs BTW1. If you're still there, thank you for joining the stream. Oh, somebody's watching the stream definitely. Okay. Again, okay. So the next stream is on Wednesday. We're going to continue with this set of papers again. All right. So, okay, okay, so that's it. I guess we'll end today. So before we finish, don't forget, again, to like and subscribe and to share the links of whatever we're doing here. We're doing it on Facebook, YouTube, TikTok, Instagram, and Twitch. I'm really most active in YouTube here, so I just want to stream it, and if I stream, you just go ahead and say hi. If I do have a lesson in those cases, I will not be entertaining too many questions from the stream because I'm gonna focus on the lesson. However, if it's what we call an open stream, then yeah, you can join in and ask questions there. Okay. So if it's a lesson, all you can do is watch. But if it's an open stream, you can actually join in. All right. So with that, uh, okay. With that, we'll just end today. So that's it again. So wherever you are in the world, that's a good morning, good evening, good day, good afternoon, good night to you, and see you next time. Stay freaky, everyone. Bye bye now.